When we are considering this cross-section and we have the desire to determine, to calculate what the strain should be at this points 1 and 2, and at these points 3 and 4 on the top flange, 5 midway up, 6 also midway, and then 7 and 8 on the bottom flange. We need to consider the distribution of stress. Now, along this cut that we have made, we said that the moment was uniform and the shear was non-existent. So, our stress distribution will look like this. We're going to have compression on the top, and tension on the bottom. And it's going to be linearly distributed as long as we have we remain in the linear elastic region for the material, which we are absolutely going to do here. So we're going to want to use this this distribution, which tells us to use this equation for our stress, and we previously stated that we could use this equation, the basic form of Hooke's law, for our strain. All we need to do now is determine the location of these strain gauges and use that along with the moment, which we already determined through our shear and bending moment diagrams, to determine this strain. Now, the experimental strain we will gather directly from here, and that will be from strain gauges 3 and 4, representing this top flange right here, 5 representing this strain, 6 this strain gauge, and then there will be 2, 7, and 8 on the bottom flange. That's going to mean that at this top location right here, so at y is equal to positive d over 2, we're going to have the experimental value of strain equal to the average of these two strain outputs. So it's going to be the average of strains 3 and 4. And this is going to be compressive, so this should be negative, because that's definitely compression. We're in positive moment, so the top should be in compression. Now at 5, we're going to be at a different location. I'm going to call that Y5. And in this case, the experimental strain is going to be equal to the experimental strain 5. And that will also be negative. Moving down, we'll be at 6. The experimental strain will be equal to whatever the strain picked up by the gauge number 6 is. But this time should be positive, because it's going to be below the neutral axis, so we're in a positive moment, so this region is going to be in tension. Finally, and y equals negative d over 2, which is to say at 7 and 8, we're going to use the average of strain inputs, outputs 7 and 8. And this should be positive as well. If we look at locations 1 and 2, there is not going to be any theoretical stress due to moment. That will only be due to shear stress.